mathematics, derivatives are used to find the rate of change of a quantity with respect to the other quantity. It is of great interest to know how it is changing. There are several real-life situations where this process is carried out. As some examples to check the temperature variation, to determine the speed or distance at various times like kilometer per hour, miles per hour, etc. So here, let's check how this derivative helps to find the values of particular functions at a point. First, we will start with the definition of derivative of a function f. It says that suppose f is a real valued function and there is a point in its domain, then the derivative of f at the point A is defined by limit h tends to 0, f of a plus h minus f of a divided by h, provided this limit exists. Also, the derivative of f of x at a can be written as f dash of a. Alright? Now, let's look at an example to make it clear. The question is to find the derivative at x is equal to 2 of the function f of x is equal to 4x minus 2. Now, let's see the solution. It is given that x is equal to 2. So, we need to find what f dash of 2. Now, what is f dash of 2? Limit h tends to 0, f of 2 plus h minus f of 2 by h. Now, after giving values to the function and calculating, we get limit h tends to 0, 8 plus 4h minus 2 minus 8 plus 2 by h, which is again, we limit h tends to 0, 4h by h, cancelling h, we get limit h tends to 0, 4, and this is nothing but the value is 4. So, the final answer we got it as 4. So, we can conclude that the derivative of the function 4x minus 2 at x equal to 2 is 4. Alright. Now, let's look at another example which illustrates a theorem that we studied earlier, that is derivative of sin x at x is equal to 0. Let's see the solution. Here, f of x is equal to sin x. Now, f dash of 0. So, we have to find the value at x is equal to 0. So, we have to find f dash of 0. F dash of 0 is equal to limit h tends to 0, f of 0 plus h minus f of 0 by h. Now, this is equal to sin 0 plus h minus sin 0 by h. Again, this can be written as limit h tends to 0, sin h by h. And what is this? This is a important result we have learned earlier. So, limit h tends to 0, sin h by h is equal to 1. So, the derivative of sin x at x is equal to 0 is 1. Alright. Next point to remember is that derivative of a constant function must be 0 at every point. It is supported by the given example. Find the derivative of f of x is equal to 5 at x is equal to 2. So, here f of x is given as 5. So, we have to find f dash of 2, that is f dash of a is limit h tends to 0, f of a plus h minus f of a by h. Here a is equal to 2, so we have to find f dash of 2. Substituting the value, we get limit h tends to 0, 5 minus 5 by h, which is nothing but 0. So, the derivative of a constant is always 0. Alright. Now, we can discuss the first principle of derivative, which is somewhat the same as the definition we discussed earlier. Taking a real valued function f and the function is defined by the limit f of x plus h minus f of x over h as h approaches 0. Wherever this limit exists, then there will be derivatives of f at that point x, which is denoted by f dash of x. So, this definition of derivative is called the first principle of derivative. Mathematically, it can be written like this. So, f dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h. And one more thing is clear from this, that the domain of f dash of x is wherever the function limit exists. Now, there are different notations for derivative of a function. Sometimes it is called d by dx of f of x. Our f dash of x can be written like this. And if the function is taken as y, then the derivative is dy by dx. Similarly, there are some other notations, that is d of f of x. If we need to find the derivative at a point x is equal to a, then we can write like this. D by dx of f of x given a vertical bar at a, df by dx at a, df by dx at x is equal to a. So we have seen the different notations. Now look at an example. Find the derivative of f of x is equal to 8x. Now to solve this, we have the equation f dash of x. For this equation represents the first derivative of a function. So here, what is our f of x? F of x is 8x and f of x plus h is 8 into x plus h. Substituting the value, and we get it as limit h tends to 0, 8h by h, which is nothing but limit h tends to 0, 8, which is equal to 8. So final answer is 8. So the derivative of f of x is equal to 8. This is nothing but 8. Next, we will discuss about the topic algebra of derivative of function. Here we have arranged these rules in the form of a theorem. And now let's look at one by one. Consider two functions f and g. Their derivatives are defined in a common domain. Then the derivative of sum or difference of the function f and g is equal to the derivative of f plus or minus derivative of g. So we have derivative of f of x plus or minus g of x can be written as d by dx of f of x plus or minus d by dx of g of x. Now next is we have to know about the product rule, that is the derivative of the product of two functions. The derivative of product of functions f and g is equal to the derivative of the first function multiplied by the second function plus first function into derivative of the second function. If f of x is the first function and g of x is taken as a second function. The above product rule can be restated in terms of u and v to recall them easily. So we consider u is equal to f of x and v is equal to g of x. So rewriting this equation, we get uv the whole dash is equal to u dash into v plus u into v dash, where u dash is the derivative of f of x and v dash is the derivative of g of x. And this is called the Leibniz rule or product rule, right? Now let's look at the quotient rule. The derivative of quotient of two functions f and g says that it is equal to the d by dx of f of x into g of x minus f of x into d by dx of g of x, the whole divided by g of x the whole square. And this quotient rule can also be restated in terms of u and v as u by v the whole dash is equal to u dash into v minus u into v dash the whole divided by v square, where u is f of x and v is g of x. Remember, in quotient rule, the sign is negative since it is a division operation. And while in the product rule, as we have seen earlier, the sign between sign is plus because the operation which we are carrying out is multiplication. Alright. Now, let's discuss another theorem, that is derivative of f of x is equal to x raised to n is equal to n into x raised to n minus 1. Now, we have to prove this theorem and we have to use the induction on n and the product rule. So d by dx of x raised to n is equal to d by dx of x into x raised to n minus 1. Now we get this as a product of two functions. So we can apply the product rule to find the derivative. So here to solve the step, we have to find the derivative of the x raised to n minus 1. So by induction hypothesis, we can write d by dx of x raised to n minus 1 is equal to n minus 1 into x raised to n minus 2. Now we have to substitute this value into this particular equation. Now substituting these values and after final calculation, we get the final answer as n into x raised to n minus 1. Hence, the theorem is proved. So, the derivative of x raised to n is n into x raised to n minus 1. There is also an alternative method to prove this theorem, but here we are proving this by the product rule. Okay. Next, we can discuss about the derivative of polynomials and the trigonometric functions. In this, we will start with a theorem that tells us about the derivative of a polynomial function. We are considering a polynomial function f of x is equal to an x raised to n plus an minus 1 x raised to n minus 1 up to a1x plus a0, where ai belong to the real number and an is not equal to 0. This condition to be satisfied. Now by using the theorem of derivative of sum of functions and product rule, we can find the derivative of this polynomial function. How? Let's see. So taking all the derivatives and we reached at the final equation, that is d by dx of f of x is equal to n into an into x raised to n minus 1 plus n minus 1 into an minus 1 into x raised to n minus 2 plus 2a2 into x plus a1. Alright, this is the derivative of a polynomial function. Now, we can find the derivative of trigonometric functions. Let's compute the derivative of cos x. Do you have any idea? The derivative of cos x is calculated by using the first principle. So here, our f of x is cos x and f of x plus h is taken as cos of x plus h. Now, substituting these values in the limit equation. So, we get cos x plus h minus cos x by h with limit h tends to 0. Now, we get this in the form cos a minus cos b. So, we have to apply this equation, which is equal to minus 2 sine a plus b by 2 into sine a minus b by 2. Putting this value, we can calculate the rest of the steps. That is, limit h tends to 0 minus 2 sine x plus h plus x by 2 into sine a minus b. That is x plus h minus x by 2, the whole divided by h. Again, we can write it like this and rearranging limit h tends to 0 minus 2 sine 2x plus h by 2 into sine h by 2 by h. Again, h by 2 can be written like this. So, we get limit h tends to 0 minus sine 2x plus h by 2 into limit h tends to 0 sine h by 2 by h by 2. And this is actually 1. The value is 1. So, we get it as limit h tends to 0 minus sine 2x plus h by 2 into 1. And we have to put the value of h is equal to 0 here. So, putting the value of h is equal to 0, we get it as minus sine 2x by 2, cancelling 2 numerator and denominator, we get it as minus sine x. So, the derivative of cos x, that is a trigonometric function, is nothing but minus sine x, right? Next, we will find the derivative of sine x into cos x. So, here f of x is equal to sine x into cos x. Here this can be computed by using the product rule. So, let u is equal to sine x and v is equal to the second function, that is v is as a cos x. Now, f of x is equal to uv form, that is u into v. So, we have to find the derivative, that is f dash of x is equal to uv the whole dash is equal to u dash into v plus u into v dash. Now we have to find the derivative of both the sine and cos separately, and we have to substitute here. So on finding derivative of sine x is what? Cos x. And v is equal to cos x, so second function. So the derivative of cos x is minus sine x. Now after putting these values in the product rule, we get it as f dash of x is equal to cos x into cos x plus minus sine x into sine x, which is cos square x minus sine square x. And what is this? This is another result which we have learned in trigonometry, that is cos 2x. So we can conclude that the derivative of sine x into cos x is nothing but cos 2x. So in this section we have discussed about the derivatives, especially we have seen the case of polynomial function and trigonometric functions. Now you are able to understand the idea of differentiation from first principle. Now let's have a quick recap of what we have discussed.
Manorama Horizon. Learning made simple.